Hi guys, today I want to look at some equations that describe our basic two-dimensional shapes. I expect this is going to be a review for many of you, but there's a few things as always that I want to highlight. This is one of the few days that we're going to spend really just looking at a whole series of equations. And these are useful equations because these are the basic shapes we would use if we wanted to describe the world around us. So it's valuable to be able to calculate some things for them. So we're going to be talking about two-dimensional shapes and area and perimeter. So first of all, I just want to highlight what these mean. Area measures the inside of the shape. It answers the question, how many squares do you need to cover it? And its units, it's counting squares. So it has units like square feet or square centimeters. You can see that this triangle here takes 1, 2, 3, and 3/2, 4.5 squares to cover it up. Perimeter measures the distance around the outside. It's how long of a piece of string would you need to stretch around the shape. So perimeter has units just of length, like feet or centimeters. You cannot convert between these. You cannot convert centimeters into square inches. These are two different sorts of units. And it's really important when you do a calculation that you write down the units and you're careful to include that squared if it is area. You cannot describe the area of a triangle in terms of miles. It would have to be square miles. Okay, so let's start with our formulas. The square is the simplest shape. The thing we need to know about the shape is its side length, S, and then its area is S squared. In fact, that's why we call raising something to the second power squaring. As for its perimeter, I hate memorizing formulas. So for perimeter, I prefer to just think about what the shape looks like. A square has 4 different sides. They're all length S. So its perimeter would be 4S square, simple shape. Now let's talk about the rectangle. Rectangle has 2 different side lengths, a side length L for length and W for width. It doesn't matter which one is L and W. Those are just a pair of names that are useful. And so its area is L times W. And I want you to think for a moment and enter the formula for the perimeter of this on the form, looking at the shape. So as you look at this shape, you'll see that it has 2 sides of length L and 2 sides of length W. So its perimeter would be 2L plus 2W. Let's move on to another circle, another shape, the circle. And the fundamental measurement for the circle is its radius. The radius is what we call R. Now be careful, because when you're given problems that start out in the real world that involve circles, it's really easy. You're more likely to be given the diameter than the radius. For some reason, I was talking about, say, a bike tire. I might say that the distance across my tire is 26 inches. And if you're not thinking carefully about that, you could use that number and just sort of assume it's the radius. So I really encourage you to draw a picture. If you draw a picture, you'll see that that number is the diameter. The diameter is twice the radius. It's a distance from one side to another going through the center. So the radius would be half of the diameter. So when we're looking at a circle, the formula for area is pi r squared. And I always have to say here what my 4th grader told me one year, which was pi r not squared, pi r round. Anyway, just had to share that. And as for its perimeter, well, when we look at circles, we usually call it a circumference, but perimeter and circumference mean the same thing. They mean the distance around the outside. So the perimeter of this circle is 2 pi r. This one you can't look at and reason out. You just need to know it. So I want you to do a problem for me. Let's say a circle has perimeter 24 inches. Perimeter is a length, so it's just the inches. What is the area of that circle? Give me your answer on the form. Okay, when we're working with circles, we need to find the radius. That is our fundamental unit. So I know that 2 pi r is equal to 42. The formula of the perimeter is equal to 42. Solve this for r by dividing both sides by 2 pi. You get r is 42 over 2 pi, which is approximately 6.7 inches. I should say here, I don't want you to leave answers in terms of pi in this class. I want you to turn them to use an approximation for pi and give me a number. My usual approximation is pi is equal to 3.14. Because we're talking about real world things and we want a sense of how large that is. And I have a better sense of what 6.7 means than what some formula involving pi. Anyway, so that's our radius. Now I just plug that into the formula for area. The area is pi times 6.7 inches all squared. That's pi times 6.7 squared, inches squared, which turns out to be right around 141 square inches, or inches squared. Always give units. Let's stop for a moment and look at these equations we've done so far. We have our formulas for area and for perimeter. I want you to notice that all of the formulas for area involve two lengths multiplied together. It might be two of the same length, side times side, or two different lengths, length times width. You can imagine more complicated shapes where you would have to add a few of these up. Like if I was attaching half a circle onto a square, I would need to have some of this added to some of that. But all of these area formulas involve length times length. And you need that. That's how you get that unit of square inches, multiplying inches by inches. Perimeter, on the other hand, is just a length. And all of the perimeter formulas just involve single lengths. You might add them up, 2L plus 2W. You might multiply them by constants like 2 or 2 pi, but you never multiply two lengths together. And to some extent, understanding this can help you remember which of the two formulas for a circle is which. We've got one more shape to look at, the triangle. Here's my triangle. It has base B and height H. As you probably remember from school, the area of the triangle is a half base times height. Okay. So what about its perimeter? Well, take a look at these two triangles. These two triangles have the same base length B and the same height H. Do they look like they have the same perimeter? I want you to take a look at them and think about that and answer on the form for me. These triangles don't have the same perimeter, right? These sides are a lot longer than these sides. And in fact, I could take this triangle and I could create a new triangle with the same base and the same height and the same area. If I took this point up here and I just took it and I started dragging it, and I could drag it like 1.5 miles that way. And the triangle I would get would have this incredibly long, skinny piece, but it would have the same area as either of these two. That's actually kind of amazing. This long, skinny triangle has the same area as this kind of shorter, simpler triangle, but the perimeter would be wildly different. So the height and the base are not enough to figure out the perimeter of a triangle. If you ever ask to find the perimeter of a triangle, you must need to use something else, and usually it's recognizing that you have a right triangle and looking for Pythagoras. So take a look at this one. I want you to find the area and perimeter. I want you to give me your answer in both feet and in meters. There are 3.3 feet to a meter, and you can always ask for conversion factors like this. You don't need to memorize it. So the area is a half of 6 times 15 square feet. 6 feet times 15 feet is square feet. That's 45 square feet. Converting that into square meters, I get that 45 square feet times 1 meter over 3.3 feet, but I have to square all of that so I can cancel out this square feet. That means I'm taking my 45 square feet and multiplying that by the fact that 1 square meter is the same as 3.3 squared square feet. In other words, I'm taking 45 and dividing by 3.3 squared in order to get it into square meters. And if you do this, you will find that your answer is 4.13 square meters. Do we care about rounding? No, this isn't a scientific notation problem. So you could tell me 4.1 square meters. You could even give me 4 square meters if you wanted to. There's my answer. Now for the perimeter, we need to find the length of that last side. So looking at this, we realize it's a right triangle. We've got to pull out the Pythagorean formula to find the length of S. S squared is equal to 6 squared plus 15 squared. So S squared, if you add that up, that's 36 plus 225. So S squared is equal to 261. S is the square root of 261. So this side length here is 16.2 feet. Converting that to meters would tell me that this side length is 4.9 feet. And of course, that's not actually the answer to the problem. I just turned this side length into meters. The actual answer to the problem would be, you may notice right now that I didn't get this on my slide, so I'm tacking it on right here. The perimeter would be equal to 6 plus 15 plus 16.2, which is 21 plus 16.2, or 37.2 feet. And if I want to convert that into meters, there's as we just saw here, there's 3.3 feet to a meter. So in meters, that would be 37.2 feet times 1 meter over 3.3 feet. In other words, take my 37.2 and divide by 3.3 to get 11.3 meters. So that would be the perimeter of this triangle in meters. Fortunately, that's our last slide. On the next video, we're going to look at three-dimensional shapes where we'll be talking about volume and surface area. Oh no, wait, I forgot. There's one more slide here. I just wanted to give you a summary of all of these equations in case that was helpful. Thank you, and please make sure you fill out and submit the form.